Alright, this is the third video. Let's talk about some identities. Some of them are standard, which are consequence of definition, meaning cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent, tangent is the ratio of sine and cosine, and cotangent is the ratio of cosine and sine. Now, one way to remember this is the tangent-cotangent relation is simple, right? Because they have the word tangent in them. But the other one is sort of the reciprocal of C is in S. So cosecant is sine, and S, which is secant, is the cosine one. So always remember that sine, cosine, tangent sort of are in one bucket, and then their reciprocals are in another bucket. So if you're trying to find, like, say, what's the reciprocal of cosine, then because it's a C, it's going to go to S, so it's secant. Or if you're trying to remember what is cosecant, then because it's a C and it's in this bucket, it's going to be 1 over sine. Some of these identities, these are Pythagorean or circular identities. The circular, you recall, we reached this by using equation of a circle. But we can also use this or get here using Pythagoras theorem. Let's say I have a right angle triangle. This is x, this is y, this is h, and this is theta. By our definition, sine theta is opposite over hypotenuse, and cosine theta is adjacent over hypotenuse. So sine squared plus cosine squared is y over h squared plus x over h squared, which is y squared over h squared plus x squared over h squared, which, take the LCM, is h squared, and this is x squared plus y squared. But it's a right triangle, so by Pythagoras theorem, what is x squared plus y squared? It's exactly h squared. So this is h squared over h squared, which is 1. So that gives you that sine squared theta plus cosine squared theta is always 1. So that's another way of proving it. You should know both ways of proving it, one using the circle and one using the triangle. Now going from here to here is it's kind of easier. So what you can do is you can verify this. 1 plus tan squared theta, right? Which is tangent is the ratio of sine and cosine. Now that means the LCM is cosine squared. So you get cosine squared plus sine squared. But you already found out that this is just 1. So this is 1 over cosine squared, which means it's secant squared. So essentially you just have to remember one identity and the two of them follow. You can try to show this one on your own using the fact that cotangent is cosine over sine. So cotangent squared would be cosine squared over sine squared. Now based on these identities, you can have problems like these. Now here we're going to combine two information. Remember how we talked about quadrants and what is positive and what's negative in each quadrant. So that's going to be important here. Express sine theta in terms of cosine theta for each quadrant. Now first of all, what do we know about sine and cosine? We know that sine squared theta plus cosine squared theta equals 1. So solving for sine squared theta is 1 minus cosine squared theta. Now we know how to solve equations with squares. We take square root. If you take square root, you end up with sine theta 1 minus cosine squared theta, but the square root can take positive or negative value, right? So here is where the quadrant thing comes into play. quadrant 1, 2, 3, 4, the rule was quadrant 1 all positive, quadrant 2 sine positive, tan positive, cosine positive. So this means that in quadrant 1 and 4, we're looking at sine. In quadrant 1 and quadrant 2, sine is positive, so we take the positive square root. But in quadrant 3 and quadrant 4, sine is negative, so we take the negative square root. Okay, so in quadrant 1 and quadrant 2, sine theta equals square root of 1 minus cosine squared theta. In quadrant 3 and quadrant 4, sine theta equals negative of square root of 1 minus cosine squared theta. Okay, next one. Express tan theta in terms of sine theta, where theta is in quadrant 2. Now we already know that tan theta is the ratio of sine theta over cosine theta. Now we want it to be all in terms of sine theta. So I need to rewrite this cosine thing in terms of sine. Now recall cosine squared theta is 1 minus sine squared theta. So cosine theta is the square root of 1 minus sine squared theta plus minus. But which of these am I going to take? Quadrant 2, only sine is positive. So in quadrant 2, cosine is negative, which means I'm going to take the negative square root. So tan theta is going to be sine theta divided by negative square root of 1 minus sine squared theta. If it was, say, quadrant 1, this would have been positive. If it was quadrant 4, it would have been positive because cosine is positive in those quadrants. If tan theta equals 2/3 and theta is in quadrant 3, find cosine theta. Now this is going to be the reverse of the triangle situation. Meaning, if you are given a trig ratio, you make a right triangle and you recall that tangent is opposite over adjacent. So you assign these values. The opposite is 2, the adjacent is 3. So the hypotenuse is square root of 9 plus 4, square root of 13. Then by definition, cosine theta is adjacent over hypotenuse, which is 3 over root 13, but quadrant 3. So you need to check. Quadrant 3 is ASTC. So tangent positive, which means cosine is negative. So your final answer, you need to add a negative here before you report the values. Now last example here, secant theta is given to be 2. Now if you are in the second group of ratios, remember how these are one group, these are one group. If you are in this ratio, this place here, you want to go over to the first group because those are easier to work with. Now secant is S, so secant is actually reciprocal of cosine. So if secant is 2, then cosine theta is a reciprocal of 2, which means it's 1/2. Thereafter, you just make the triangle. This is going to be square root of 3. So sine theta is going to be root 3 over 2. Tan theta is going to be root 3 over 1. Cosecant theta is reciprocal of sine, 2 over root 3. Secant theta is already 2. Cosine is already 1/2. And cotangent is reciprocal of tangent, 1 over root 3. Those are the values, but you're not yet done because you're in quadrant 4. Quadrant 4 is ASTC, so cosine is positive, so this is fine, which means the reciprocal of cosine is also positive, but everything else is negative. So you have to add negative to all of these. Now because you're in quadrant 4, the sine, tangent, cosecant, cotangent values are negative, but the cosine and secant values are positive. Now, as a conclusion to this section, the point is that there is a relation, or we can take this leap from trigonometric ratios to trigonometric functions, and we write them as y equals sine x. And the input, that is x, is going to be angle, and it returns a real number as output. And what is this real number? It's the ratio of the, in this case, opposite to hypotenuse in a right triangle that has an angle equal to input. So for example, if I say y equals sine x, and let's say x equals 32 degrees, I plug into the calculator. Make sure it's in degrees. So I plug in sine of 32 and I round it off, so this is 0.53. Now this is as a function, but what this is really saying is that if I take this triangle, if I take any right triangle and I make this angle equal to 32 degrees, and I measure opposite and I measure hypotenuse, then in this triangle, the ratio of these two is going to be exactly 0.53. Or in other words, if I think of this as say 0.53 over 1, right? One such triangle would have this length 0.53, would have this 1. Now let's verify. Let's try to solve for this x. Let's call this L here. L is going to be 1 minus 0.53 squared in the square root using Pythagoras. Square root of comes out to roughly 0.85. So let's verify, which means that if this is correct, then using this triangle, cosine 32 should be 0.85 roughly. Let's verify. Cosine of 32 is 0.848, which is true. So I can verify here. If I instead looked at this function and I let x be 32 degrees, then y is in fact approximately 0.85. Similarly, based on the definition of this triangle, tangent should be 0.53 over 0.85, roughly 0.62, which means if I take the function y equals tan x and I plug in 32 degrees, I should get that value. And let's check. I do get roughly 0.62. So what we established here is that by starting from a triangle, we are able to define these 6 functions now, which are on real numbers. What do these functions do? They take an angle as input and they return a real number as an output, and that real number corresponds to a right angle triangle which has one of its angles as the input, and it tells us everything about that triangle. And remember from our activity, this triangle, there are infinitely many triangles with the same angle 32 degrees, and they all have the same ratio. So this makes it a really powerful tool. This is where we're going to stop.